Okay, today we're going to go over how power actually gets to our outlets, how it gets to our lights. When we're doing projects here, we just plug them in and hopefully did it right that it works. But here, we don't just like the power in the house just isn't mysteriously there, so we're going to show you how it actually gets to your house. So from your utility pole outside, you have two lines running into your meter base. Comes out of your meter base going to your panel box. We have this up here representing your panel box. So we have two wires running in that actually carry power, plus our grounding neutral wire that I didn't draw in here. But our two feeds coming in we refer to as legs. Each leg carries 120 volts. Comes through the main and then it energizes the bus bar. So what we have here is representing the breaker slots. Now you'll notice like where if I took power from the number 2 breaker, so I'm going to actually run my wires from that breaker and then probably feed an outlet. Then from that outlet I could feed multiple outlets and then feed a light switch going up to my light. So the power is coming from the panel box. And we have the breakers that go in there. And these breakers are rated between, for a single pole, 15 and 20 amps. So now my 15 amp breaker here, and it's feeding just outlets. Now for my larger devices, let's go with my dryer. That requires 220 volts. So instead of just picking up one leg, I have to pick up both legs. And as you can see in the panel box, the bus bar zigzags. This way when I put in my double pole breaker, it picks up one leg from one and one leg from the other, giving my 240 volts total. If I took 120 volts from 1 and 5, they're on the same leg. It's not going to give me 240. It's going to just be, since it's the same leg, it's going to be 120 volts. So that's why we zigzag them. This way it's picking up a leg from each one, giving us the total of 240. So your 240 devices are your large thing. Well pump, your dryer, hot water heater, things such as that. Your stove, they're going to require the 220. Your smaller things is your outlets, your lights, they're only 120. So you gotta realize you'll see numbers of 120, 110, 115. That's all the same. Same thing with 220. It's either 220 or 240. They're still the same. It's just at the time what people are calling it. So don't be confused by a 220 or 240. It's the same thing. Same thing with 110, 120, 115. They're the same thing also. So now when we're calculating for breakers, we got to realize even though this is a 15 amp breaker, we can't load our circuit to 15 amps. We have to use the 80% rule, because anything that runs for 3 hours or more is considered a continuous load. So technically I could leave a light on for 3 hours or more, so I only could load that 15 amp breaker to 80%. So that 15 amp breaker could only actually be loaded to 12 amps. Same thing with a 20 amp breaker. I could technically only load that to 16 amps, because then I'm using the 80% rule. But back to the beginning, how we get our power is these are coming from the pole, goes to the panel box to my breaker. Power comes out of my breaker, feeding my devices. And like in the case of your outlets, you're going to have multiple outlets on, or multiple rooms. 220 is usually for a single device, so like a dedicated device. So like I said, you know, your dryer, your range, your water heater. Electric baseboard heat could fall under there, because that's going to be a 220 device. So I hope this helps you understand a little better how the power gets from the outside to the actual device inside your house. That's it.